this tutorial, we'll be integrating an accelerometer into our Werkstatt. This will give us the level of gestural control over certain parameters. For this project, you'll need a 10K resistor, a 2.2 microfarad capacitor, an ADXL335 SparkFun widget, and an Arduino. You'll also need a way to upload code to your Arduino. The ADXL335 is an accelerometer, which can sense motion in a three-dimensional space. On the accelerometer itself are 3 pins for X, Y, and Z. You'll also have a pin for power and a pin for ground. First, place your ADXL335 into the breadboard. The ADXL335 takes 3.3 volts for power. So run a power line from your Arduino 3.3 volt out into the power pin on your accelerometer. Next, run a ground line from your accelerometer to the Arduino. The next 3 pins, X, Y, Z, give you information depending on where the accelerometer is in dimensional space. These all need to run into an analog input on the Arduino. For the code, I have it set up to run XYZ into A0, A1, and A2. That's it for connecting our accelerometer to the Arduino. If everything's connected correctly, the accelerometer should be sending data to the Arduino that we can then send to our Werkstatt. In the code, you'll notice that there's 2 separate functions. One just named XYZ axis, and the other named X, Y, or Z pulse. The X, Y, or Z axis function sends out a pulse width modulated voltage. For this voltage to be understood by the Werkstatt, we need to pass it through a low-pass filter that's identical to the one in our arpeggiator mod tutorial. To make our low-pass filter, we'll need to send our signal into one end of our 10K resistor, and then connect the other end of our 10K resistor to the positive end of our 2.2 microfarad capacitor. Now, the capacitor is delineated between positive and negative with a white line on the negative side of the capacitor. Go ahead and attach that white line, or the negative lead of the 2.2 microfarad capacitor, to ground. For the X, Y, or Z axis functions, in the code you'll see that we are sending out of pins 9, 10, or 11. That's because these 3 pins in the Arduino provide us with a true PWM signal. For this example, I'll be running the X-axis information out of pin 9 into one leg of our 10K resistor. Now for our Y and Z signal, I'll be using Y and Z pulse. The pulse function sends out an on or off with a varying frequency out of our digital outputs. In the code, you'll see that these are synced to digital output 1, 2, and 3. Since we don't need to filter this signal, we can just run this straight into the Werkstatt. Once everything's plugged into your breadboard and in the Werkstatt, we're ready to upload our code. At the top of our code, you'll see that we call and name our accelerometer class, and then define the input pins, A0, A1, and A2. Here in the loop, you'll see the X, Y, and Z axis functions. Since we're not using Y or Z, we can go ahead and comment these out. And here you'll see the X, Y, and Z pulse functions. Since we're not using the X pulse function, we can go ahead and comment that out as well. Now the function input parameters are as follows. The pin that we'll be outputting to the Werkstatt, and then the minimum and maximum values that we want to be sent to our Werkstatt. By changing the minimum and maximum of these values sent to the Werkstatt, we can create more dramatic effects. Go ahead and feel free to experiment with these. Finally, we'll need to make sure that our Werkstatt is sharing the same ground as our Arduino. By using an accelerometer in our Arduino, we were able to add a fairly unconventional control over our Werkstatt. With some more development, we could add an XB or a Bluetooth shield and make this mod wireless, which could then be put on a glove or a suit or anything. All fritzing models, code, schematics, and parts list are available online at werkstattworkshop.com. We encourage you to use our code as an architecture and build upon it to create your own gestural control for the Werkstatt.